Good morning and welcome to another exciting edition of Maths with Mr. Newman. Today's topic, we're going to be solving inequalities. And to start that, I've written some quadratic equations for us to solve. So at this point in time, I'd like you to have a go at trying to solve these. Start with questions 1 and 2, and then progress down to question number 10. Of course, ask me for help anytime you may get stuck. Yes, of course, I can help you out with question number 1. So I'll give you a paired question. So just up here, we'll call this question 0. Imagine we had a quadratic equation already factorized, which is good. And I'll start with both positives, x plus 7, x plus 5 equals 0. So we're going to find that there are two solutions to this equation, and I'll just break it down from here. In order for one of these to equal 0, we have something on the left inside brackets, we have something on the right inside brackets, and they're multiplying. There's a secret multiplier between the brackets. So whenever we have brackets next to each other, they are multiplying. In order for something to multiply to make 0, what does one of the things have to be? Yes, that's right. One of them has to be 0. So imagine the bracket on the left is equal to 0. How do we solve this equation? Yes, minusing 7 from both sides. Very good. So we will have x equals minus 7. Good. And this is one of our solutions, okay? Yes, the other one is x equals negative 5. Very good. Okay, carry on. Thank you. Excellent. So you managed to do questions 1 and 2. Yes, question 3 onwards, we have to factorize. And do you remember what factorize is? Yes, put into brackets. Good. So we have to first put them into brackets, just like questions number 1 and 2. Yes, of course. Question 4 has a negative. Let's remove this. So for question number 4, so we'll start with x squared minus 3x minus 10 equals 0. So the tricky part here is the negative 10. Do you know the factors of 10? 1 and 10, good. 2 and 5, fantastic. Yeah, that's all of them. We need factors of negative 10. So how do we change these? No, they won't both be negatives because they were multiplied to make a positive. Yeah, it's just one negative. And are there any more factors of 10 or negative 10 that we haven't got up there? Yeah, so the opposites, which also have the negatives. Good. And we'll find that one of these pairs does indeed add to make this here. Now, I'm not going to circle 3x, I'm going to circle negative 3x. So one of these things here, yes, that's right. This one here adds to make those. So we can put these inside our brackets now. Good. So our brackets are going to be fantastic. And can you solve that from there? Good. So carry on. Okay, yes, question 5. So suddenly we have a coefficient greater than 1, coefficient of x squared greater than 1. Okay, and that's when we have the quadratic form like this. And this value here is greater than 1. So what we like to do here is what I refer to as the AC method. So I'll run through that with you right now, and then you can have a go at questions 6 and 7 and 8. And then we'll see if you need help with questions 9 and 10. So we have 2x squared plus 7x plus 3 equals 0. The AC method takes both of the A and the C values and multiplies them together. In this way, we're able to get a value that we can split this into, okay? And we'll talk more about that in a moment. So the AC, A multiplied by C equals, so 2 multiplied by 3 equals, okay? And now we can get the factors of 6. So the ways to make 6 are yes and very good. Okay, only one of these makes our 7. Yeah, that's right. So we're going to use these two. So we're going to split this into 1x and 6x. Doesn't matter which way round, we can do it both ways. So we can put the 1 first and the 6 second, or the other way around. It doesn't really matter. It will both give the same answer in the end. So let's rewrite this as 2x squared plus 1x. And yes, I'm just going to write 1x. Normally we would write x, but plus 6x and plus 3 equals 0. What we're going to do is we're going to factorize both of these pairs now. So this one here, we're going to give that a factorization. We're going to do the same for this over on this side. And the idea is that once we factorize both of these, we're going to have one thing in common with both. And we'll see that in a second. So what factor goes into both of these? Doesn't always have to be a number. Yes, that's right, x. So we have x, and then what's left over to make 2x squared? 2x, very good. And then 1. And you can see why I may have wanted to keep it as a 1, because there is a 1 there. And then on this side, we factorize by doing, yeah, they both have a 3. And then they both got the 2x plus 1. That's right. And what we'll see is we have x multiplied by 2x plus 1, and we have 3 multiplied by 2x plus 1. So we have, essentially, we have an x plus 3, both multiplied by 2x plus 1. And we can write that as, in brackets, we have an x plus 3, both multiplied by a 2x plus 1. And that equals 0. So we have now factorized that fully. We factorized this expression into 2 brackets. Now we're going to solve, because we're solving equations. Yes, x equals -3. No, in this situation, x does not equal -1. So why don't we set this up as an equation rather than jumping straight to what we think the solution might be? So the equation is 2x plus 1 equals, yes, 0. 2x plus 1 equals 0. Okay, how do we solve this two-step equation? Yep. And then we have to sever the connection between the 2 multiplied by x. So what's the opposite of multiplication? That's right. And so we just write it as a fraction. So the fraction is, it's not a half, it's not 1/2. Yes, it's -1/2. And so what we'll find is we have a whole number, an integer value here, and we have a fractional value here. Yeah, don't write it as decimals. Fractions are much better. Yeah, so carry on with the next set of questions, and we'll move on from those. Yeah, so question 7 is a bit harder because now we've got a negative, but that's okay. We can work it through. So 4x squared minus 4x minus 15 equals 0. So first things first, yes, to AC. So AC equals, it's not 60, it's -60. Good. Okay, so now we have to do the factors of -60. There's going to be quite a lot of factors of -60. Yeah, the first one is -1 times 60. We might be here for a long time. That's okay. We can do all of the factors, or we can see which ones might give us a value closer to -4. So we're looking at values that are close together. Okay. So -3 times 20. Okay. That doesn't quite meet that one yet. -6 times 10. Okay, so this is closer. What does that give us? 4. Good. Yes, that's right. 6 and -10. Good. So you've got them the right way round. So yeah, feel free to do the positive ones if you're more familiar with them, and then use that for the negative. So these are our values here, 6 and -10. So I'll just get rid of this. So we have 4x squared. And what was the values again? 6, -10, good, and -15. What have I forgotten? That's right. Sorry, let's stick the x in there. So yeah, easy mistake to make. And yeah, just partially factorize each of these. Have a go at that, and let me know if you get into any problems. Okay, I'll just check to see. And then what do we do here? So you factorized by 5. Okay, so plus 5. And then what did you have? Yeah, and okay. So what's the problem here? Yeah, okay. So one has a set of negatives, one has a set of positives. What sort of thing might we have needed to have done rather than factorize by 5? Do you think there's a different value we could have chosen? It may not be a positive number. I think I've given the game away. Yeah, okay. So it definitely would have been a negative 5 in this situation. And that would have made this a positive 2x and a positive 3. And then just changing this to a minus 5. Do you think you've got it from here? So yeah, we have 2x minus 5, 2x plus 3. Very good. Yeah, and these are both going to give fractions. Very good. Yes, you've got question 8. Very correct. Good. Question 9, more difficult because now we've got a negative number at the start. Let's see what we can do. Yeah, I think you made a mistake on one of the negatives on here. So let's teach you how to do question 9. There are actually two methods to do this. I'm going to go through both, and you feel free to choose which one you find better. So first things first, regular old AC methods that we're pretty familiar with by now. Um, just the negative numbers thrown us off. So AC equals, that's right, yeah, negative 16. So yeah, looking for the factors of negative 16. Good. Yeah, it is that one. Okay, so negative x squared minus 2x plus 8x plus 16. Yeah. We could have had them both, yeah, around both ways. So you put the 8 first, did you? Yeah, that's fine. We could have done that. So I'll just change that. And factor that goes into both of these. Okay. And then both of these. Okay. And the good thing is these are both the same. So bracket 1, bracket 2. Yeah, okay. So I see where you've got the problem with. Why don't we have this, set this one up as the equation? So, and good. And you've got this one already. Yeah, so this one, negative x equals negative 8. Yeah, so x equals positive 8. Good. Okay. Yeah, so we had our positive value and a negative. There won't always be one positive, one negative. They might both be positive or both be negative or one of each. And let's have a go at question 10 then. Excellent. Yeah, question 10 is all correct. Going back to question 9, there was another method we could have done to get rid of this negative. Any ideas what that might be? Okay, well, I'll let you know then. If, because this is a 0, that won't change, but we can multiply all of this by a -1 or divide by -1. And in doing that, if we multiply through our entire equation by a negative number, we can make all negatives positives because multiply by a -1, we get that. Multiply by a -1, oops, we get that, and we get. And so we could have factorized this as if it was in this form. So that was a shortcut we could have done in this question. And likewise, in question number 10, we could have multiplied by a -1 as well, and to get all of our terms in the positive. So that's not quite done. We're not quite there yet. I'll just put the answers up on the screen in case you needed to see them from here. But I think you've got all of these anyway. So just give you a moment to mark through these. And yeah, writing them as fractions, as you can see, far easier. Nobody wants to deal with a -7 divided by 3, do they? Um, when it comes to sketching graphs, it may be a good idea to evaluate the fractions into decimals so that you know whereabouts they lie on a number line. But when we're sketching them, we don't need to. We can just label them as they are. Okay, so our title today was Solving Inequalities. And so on the screen, we have inequalities. What do we notice about what I've done here? Yeah, that's right. I've paired them with the previous questions. That's because solving inequalities could be done exactly the same way as solving equations. The difference is with the inequality part. So let's just go back to our solutions here. What I'd like to do at the moment is, and to work with you on this, I'd like to sketch Cartesian graphs, simple Cartesians like so, okay, with our x and our y, and plot what we think our graphs are going to look like by using the solutions that we've got. So with the first one, a 3 and a -5, yeah, so they're x equals 3 and x equals -5. Good, so we find where the 3 is, and we find where the -5 is. Now in sketches, we tend to do this. Pen's a bit bold, actually. I've used a thinner pen. Okay, and so we can draw our rough shape of our graph on here. Okay, if we can get rough shapes of graphs, it makes solving inequalities that little bit easier. Because in the first question, we have a greater than 0. So we have solved the following inequalities. This was the solution on the graph for our graph x, already factorized graph, x -3, x plus 5. So we've drawn this graph on here. The inequality, rather than having the equal sign, it had the greater than sign. So it's now an inequality. And what we want to see on this graph is any values, any solutions greater than 0. So we only want the graph greater than 0, which means we're ignoring part of the graph. Okay? Which part of the graph? So we're looking at the x values specifically. Which part of the graph are we going to ignore? The above the graph or below the graph? Yeah, we're going to ignore below the graph because this is saying greater than. So we only want the solutions greater than 0. So above the graph, we're going to keep. Below the graph, I'm just going to dot it to show that we don't want it. Okay. I'd still like to see what the graph looks like. I'm going to make this bolder. And we're going to use some inequality to show our solutions. So rather than having the solutions x equals 3 and x equals, I'll put it down here, x equals -5, well, let's put these as inequalities. What values are these? Are they going to be less than or equal to or greater than 3? Yeah, they're going to be greater than 3. Good, because we've got our 4 and our 5, etc. So instead of x equals 3, it's going to be x, good, greater than 3. And on this side, instead of x equals -5, we're going to have x is, okay, good, x is less than -5. Now, can we put both of these inequalities together? Okay, so you're saying we can do that. Doesn't quite work. Can we see? So x is not between these two values. It's that side and that side. So we have to write it. I mean, we already have it written down already. But we don't want to do that last step because it doesn't apply for this. So yeah, this is indeed our equation written, or our inequalities written side by side. So these are the values that x can be. Remember, it's not in between these. So have a go at the second question and see if you get a different set of results. Good. So for the second question, yeah, you had them plotted at -2 and -7 again. And so our graph looks like this. And yeah, so it is this region here. So let's just going to remove part of this and make this bolder. So yeah, it is this region here between the -7 and the -2. And you're right, x is greater than, for the less than, sorry. X is greater than -7 and x is less than -2. Yeah, we can put these together. Good, very good. So we can put them like so. Okay, and we'll see. Make sure you get them the right way around. It makes sense, doesn't it? X is bigger than -7. Remember, big is this side. Even though we're dealing with negative numbers, big is that way, small is that way. Okay? So have a go at the rest of them. No, it doesn't change a thing really when we're doing this, when we have the or equals to. So it's just an extra little dash for that. So keep going with these ones. As long as you've got the answers, the solutions correct from the last set of slides. We shouldn't have a problem with any of these really. Okay, very good. So thank you for that. Your number eight, you seem to have got your inequalities the other way around. So have another try at that. Okay, yeah, you've seen your mistake on that one. Good, but yeah, the rest is very correct. So drawing near to the end of our times. So these are the solutions, how they're written. Note that I've put a comma earlier, and they've used the word or between these. It's fine. Either way around is okay. Um, in A level, they'll sometimes want you to use curly brackets with the U sign for the set notation. It's not too big a deal for that, not too big a jump.